You have likely solved a large number of equations in high school. This lecture is not about solving equations, it deals with the terminology of equations. First of all, what is an equation? Well, an equation is simply a statement, and a statement is a proposition that can be either true or false. An equation is a special type of statement, namely a statement of an equality. This means that it always contains an equality sign and two mathematical expressions, one on each side. For example, in the equation 2x plus 1 is equal to 3x minus 4, 2x plus 1 is the left-hand side expression, while 3x minus 4 is the right-hand side expression. An equation must contain at least one variable, typically named x. When x is equal to a specific real number, say 2, both the left-hand side and the right-hand side can be evaluated as real numbers. In this case, 5 and 2. 5 is not equal to 2, which means that the statement is false when x is equal to 2. When x is equal to 5, the left-hand side and the right-hand side are both equal to 11, and the statement is true. The important point is that an equation will be true for some values of x, and it will be false for other values of x. The main goal is to find all the values for the variable x, which makes the statement true. This is also why the variable is sometimes called our unknown. We are trying to find its value. Any value for x which makes the equation true is called a solution to the equation. In our example, 5 is the only solution. Our example is an example where we have one equation or one statement and we have one variable. Equations are not restricted to a single variable. You can have an equation with several variables, and in this case we typically name them x and y if we have two. A solution is then any combination of x and y which makes the equation true. For example, x plus y is equal to 1 is an equation with two variables. This statement is true if x is 1 and y is 0, but it's also true if y is 1 and x is 0, or x is 1/2 and y is 1/2, and so on. In this case, we have an infinite number of solutions. You can also have several equations or statements viewed as a whole as one statement. We then say that we have a system of equations. For example, I could have a system of two equations and two variables, such as x plus y is equal to 2 and x minus y is equal to 0. We add an opening curly parenthesis like this to illustrate that these two equations are to be viewed as a system. In general, we can have any number of equations as well as any number of variables. The number of equations does not have to match the number of variables. For a system of equations, the solution must satisfy all equations. For example, x is equal to 2 and y is equal to 0 will make the first equation true, but the second equation false, and therefore this is not a solution. However, if x is 1 and y is 1, then both equations are true, and this is a solution to the system. It is possible for an equation to have no solution, as this example demonstrates. There is no real number x whose square is negative. The square of every real number is non-negative. Another example would be x is equal to x plus 1. The right-hand side will always be one unit above the left-hand side, and the equation can have no solution. It is possible for an equation to have one solution. For example, 2x plus 1 is equal to 5 has only one solution, 2. An equation can have precisely two solutions. X squared equal to 1 has two solutions. x is equal to 1 and x is equal to -1. We also have equations with precisely 3 solutions. For example, this equation. When x is equal to 1, the first term is 0, so 1 is a solution. Similarly, 2 is a solution as it makes the second parenthesis 0. And the third solution is x is equal to 3. We can also have equations with 4 solutions, 5 solutions, and so on. An equation can have an infinite number of solutions. We have seen one, x plus y is equal to 1. Another example, although somewhat silly example, would be x is equal to x. An equation which is true for all values of x, like this one, is typically called an identity rather than an equation. For example, x plus y times x minus y equal to x squared minus y squared is true for all values of x and y, and we call this an identity rather than an equation.